With this activity, look at the list of items on the left and determine whether each item is an acid or a base. And then following the directions above, make an X or a check mark in the box beneath the acid or base. You can type it, you can use any tool, however you can get the job done. Indicate whether the substance is an acid or base by making a mark in the appropriate column.
Okay, you are going to use pages 626 and 627 in your textbook as you complete this next section, so you can have your textbook open. A summary of these pages says that some acids are stronger than others. For example, vinegar and lemon juice are acidic, but they're not very strong. The acid in batteries is very strong and dangerous. Similarly, bases come in different strengths. Soap is a base that is safe for daily use, but lye is a base that will burn your skin.
The pH scale is a way to measure the strength and weakness of acids and bases. So you can see in the picture some specific examples on the pH scale taken from your book. The acid in a car battery, for instance, is very strong. Its pH can be as low as 0, whereas a lemon drink contains citric acid, which has a pH of about 2, which isn't as strong. A vinegar solution of acetic acid, it has a pH of about 3. Distilled water is in the center. It's neutral and has a pH of 7. Milk of magnesia is a weak base. It has a pH of about 9. Drain cleaning liquids are often moderately strong bases. This one has a pH of about 10, and ammonia is a moderately strong base as well, with a pH of 11.
The pH scale ranges from 0 to 14. Neutral is in the middle, it's 7. If a substance is neutral, it is neither an acid nor a base. The pH of acids is less than 7 down to 0. The lower the number on the pH scale, the stronger the acid. The pH of bases is greater than 7 up to 14. The higher the number on the pH scale, the stronger the base. For example, though, one thing that can be confusing, sometimes acids and bases can move by half numbers. So when we say greater than 7 or less than 7, like even 6.5 would be less than 7, or 7.5 would be greater than 7. So don't think that every acid is an exact increment on the pH scale. They sometimes are a little bit in between the numeric increments.
We can measure the exact pH of an acid or a base with wide range indicator paper, again pictured in the bottom right. The wide range indicator papers turn different colors depending on the pH level of the solution. A corresponding key or diagram shows what the pH value of each color change means.
The flowers of many plants can range in color depending on the acidity or the alkalinity, the level of the base, of the soil. For example, we've got deep blue all the way to deep pink. And so the deep blue, this is the same flower, but it might have a deep blue color if the soil is a more acidic level. But as it gets closer to neutral, then the flower might have a more deep pink color. And again, here's that increments moving by half steps rather than the full number. So just be aware that acids can move by half increments, but also acids affect the way flowers and plants look.
Take a minute to watch the video down below what you're watching right now. Check it out. And then when you're done, continue on with the list of assignments and come back to the video below it.